Well, hey guys, I'm back with the second half of these circle variation questions. These questions come off of released ACT exams. Some of this will also help you with the SAT, by the way. It's really important to understand that the fundamentals based around these circles. And once you grasp those fundamentals and those fundamental equations, you'll be just fine. Now, keep in mind, one of our purposes to create these videos is to try to help young adults who don't have any help outside of school. And if you would like, share and subscribe to our channel, perhaps they could run across our series of videos that we're creating. Now, with that in mind, before we actually dive into the problems, I want to give you a little background information about some of the equations that's important to be familiar with for circles. So let's get rolling. Okay. One of the equations it's really important to be familiar with is this one here. Let me set this up for us. X minus h squared plus y minus k squared is equal to r squared. Now, h and k come together to make the coordinate pair for the center of the circle. And r is the radius. Okay, now when the center of the circle is at 0, 0, this equation gives us a 0 for h and a 0 for k, and therefore the equation becomes x squared plus y squared is equal to r squared. Now, the ACT likes to use either one of these equations, this one or this one. With that being said, these problems that I'm going to be showing you is going to revolve around these equations. So let's move forward. First question. A chord 24 inches long is 5 inches from the center of a circle. So 5 inches from the center of the circle. So we know that's the center of the circle, and the center of the circle is just 5 inches from that chord that's 24 inches long, setting up a right triangle. It says, what is the radius of the circle to the nearest tenth of an inch? Well, let me change my color of my pen tip. And if this is the center of the circle, coming straight down splits 24 in half. So therefore, this side of the triangle is 12. And from the triangle leftward is 12. So now we've got some information that will help us get the radius of the circle. So let me change my pen tip back to white. With that being said, we can use a squared plus b squared is equal to c squared, Pythagorean theorem, to figure out r. So this would be 5 squared plus 12 squared is equal to c squared. And c is going to be our r value. So 25 plus 12 squared is 144. Now 25 and 144 is 5 and 4 is 9. So 169. That's equal to c squared. I got to get these glasses fixed. Okay, now we got to take the square root of both sides. So the square root of 169, square root of c squared, leaves c. Square root of 169 is 13. And that's going to give us our answer choice, D as in dog. let's go to the next one. Okay, now notice our answer choices. They're in that format of x minus h squared plus y minus k squared is equal to r squared. And they also have the x plus y, x squared plus y squared is equal to r squared as well. So now these equations are popping up. Let's leverage them based off what we know to answer the question quickly. A circle is in the standard coordinate plane, tangent to the axis at 5 and tangent to the y-axis at 5. So x-axis at 5 and y-axis at 5. Okay. I'm going to sketch a little graph here. And real quick, just to give us an idea what they're saying about the circle. All right. So this would be 10, 1, 2, 3, 4, 5. Here's 5. There's 5. There's 10. So it tells us the circle is tangent to the x-axis and tangent to the y-axis. So tangent means it's going to touch one point at both of these. Which of the following is an equation of a circle? So we can come across here and here. 5 and 5 meet right here. That's going to be about the center of our circle right there. Now, once you know where the center of the circle's at, you can go ahead and answer this question real quick. But I'm going to go ahead and just sketch the circle so you can see what it means by being tangent to both of those axes. And it isn't going to be a perfect circle because I'm no Picasso. But notice it only touches one point here and one point here. That's being tangent to those axes. And we know the center is 5, 5. With that being said, we can now jump directly to our answer choices. Now, remember, we want to model either the first one or the second one. In this case, we're going to look at modeling the first equation. So our h and our k would be a 5 and a 5. So we would say x minus 5 squared plus y minus 5 squared is going to be equal to 25 because our radius goes from here to here, which is a 5. So it's going to be 25. And our answer choice is going to end up giving us answer choice D. Okay, let's go to our next question. So this question, they've already got a circle and all the points set up around it. And it says in the standard coordinate plane below, the vertices of the square has coordinates 0, 0, 6, 0, 6, 6, and 0, 6. Which of the following is an equation of the circle that is inscribed in the square? Well, where would our center of our circle be at? Well, that's easy. We know from the origin to 6, 0 is 6 units. So half of that's going to be at a 3. And the origin from on the y-axis to the y value where it intercepts the graph is 6. So half of that is 3. So we're going to be at about 3, 3. So our center is going to be 3, 3. That's our HK value. And once you notice that, then this becomes very easy because again, we're going to model this equation, x minus h squared plus y minus k squared is equal to r squared. And we know the center is a 3, so x minus 3 squared plus y minus 3 squared is equal to, well, the radius is going to be a 3 because the center's at 3, 3, so it's going to be 9. And that's going to be our answer choice A. Now, I want you to check out answer choice C. Do you see why answer choice C is wrong? In answer choice C, they have plus signs instead of minus signs in the equation. So please be aware, be careful with that. All right, let's move on. Now this one, we have a circle that's offset here, and a portion is below the x-axis. And notice they've identified the center as being 2, 1. And they want us to pick the equation again. So we know let me draw on this. We know from here to here is the radius. And we know our y value is 1 unit. So we're 1 unit above the x-axis. And then our y value below the x-axis is a -1. So that's 1 more unit below the x-axis. So our radius is 2 units. So we're going to look for something. The radius squared is going to be a 4. We know the center is 2, 1. All right, so let me get back over here. Again, we're looking for an equation with something of this standard, or this form, if you want to say. Well, the radius is 2, so it's going to be 2 squared, and that's going to be 4. We know the center of the circle is 2 and 1. So it's going to be x minus 2 squared plus y minus 1 squared is equal to 4. And that's going to give us answer choice x minus 2 squared plus G. Now notice J, they put plus signs but for the 2 and the 1, and they put a 2. Don't fall into a trap. And notice K, they put +2 and +1 with the right radius. The radius squared, in other words, of 4. So be very, very careful about these signs right here. Okay? Very careful with them. Let's move on. So this is an interesting problem. And as soon as you see it, you're probably thinking, what the heck's going on? But if you just take the time, take a deep breath and read it, it gives you enough information to really understand what's going on. So it says 4 congruent semicircles. So congruent means these semicircles are the same, touch only at their corners. If the path from A to B along the diameters of the semicircle is 100, so from A all the way to B is 100. How many centimeters long is the path from B back to A pertaining to the arcs? So the arc distance all the way back from B to A, what is that distance based on knowing the distance from A to B is 100? Well, if the distance from A to B is 100, and there are 4 divisions here, right? divide that by 4, and you know each one is 25 centimeters long. So that implies the diameter of the circle is 25. Okay, so we need the arc distance. So that's related to the circumference of the circle. So 2 pi r. If you know the diameter is 25, the radius has to be half of that, or 12.5. So 2 pi times 12.5. Sorry about my 12.5. Now 12.5 times 2 is 25. That's 25 pi. So with that being said, that's the circumference of one circle. So we've got to get another 25 pi for the circumference of the second circle. So 25 pi plus 25 pi is going to be equal to 50 pi. That is the total distance back from B to A along the circle. And that's going to give us answer choice G. Okay, we got one more. And here again, notice what they give us. Now, we're still working with the same form of the circle equation. But notice they give us x minus 5 is equal to 38. Now, there's no k value here, so that means the k value was 0. So the 5, so when there's no k value, we know there's a 0. When there's no h value, you know that's a 0. So in this case, our h is a 5, and there's no k, and so that implies 0. So the center is 5, 0. And that's pretty obvious because in F, G, and H, J, K, they give you the option 5, 0 or negative 5, 0. But now you know it's positive 5, 0. Okay, now what are the radius of the circle in coordinate units and the coordinates of the circle, center of the circle? So this 38 is the radius squared. So the square root of 38 is equal to the radius. Okay, so now we have the square root of 38 and 5, 0. And that's going to be answer choice 3850 is F. All right. Now, those were some quick questions that have been taken off various ACT exams, centering on circles. If you really understand that formula, x minus h squared plus y minus k squared is equal to the radius squared, it will really help you get through these problems quickly. Instead of being intimidated by them now, you see how easy it really is. Okay, guys, I hope that whenever you're planning your exam, I hope that you score what you're looking to score, and I wish you all the best. Stay focused on what you need to be doing, get it over, get it behind you, and don't look back. All right, you guys have a great night.